Module Technical Course Additive Manufacturing for Industry 4.0. Lecture 1, Introduction to the course. During this presentation, we will discuss the structure of the course, the knowledge and skills that student will gain as a result of the course. Besides, some basics of additive manufacturing will be introduced to you. After completing this course, the student will be able to develop and use methods and tools for intelligent design and additive manufacturing of technical objects and structures, and evaluate the results in terms of the quality of the final product and resource constraints. The knowledge that the student will gain as a result of the course is: student acquires the vocabulary necessary to navigate the complex landscape of additive manufacturing equipment, materials, and applications. Student understands the fundamental principles and workflow for additive manufacturing various materials and how these principles govern the performance and limitations of each mainstream additive manufacturing process. The skills that the student will gain as a result of the course are: student learns to identify how, when, and where additive manufacturing can create value across the entire product life cycle, from design concept to end of life. Student knows how to select an additive manufacturing process and material for a specific application. Student is trained in the skills necessary to design parts for additive manufacturing that combine engineering intuition with computationally driven design and process-specific constraints. The competencies that the student will gain as a result of the course are: student can assess the value of an additively manufactured part based on its production cost and performance. Student can estimate the business case for transitioning a project to be made using additive manufacturing versus the conventional approach, either in part or in whole. The full program of the course includes 3 lectures, set of laboratory works that are aimed at creating and studying a virtual prototype of robot manipulator in cryoparametric for further manufacturing of its physical prototype, as well as case study, research and development of additive manufacturing process and material for specific application. So, additive manufacturing is a process of joining materials to make objects from 3D model data, usually layer upon layer, as opposed to subtractive manufacturing methodologies. Additive manufacturing is the exact opposite of traditional mechanical production and processing methods, such as milling or cutting, where the shape of the product occurs by removing excess material, so-called subtractive manufacturing. Let's see this video from University of Cambridge to understand the basics of additive manufacturing.
How would you like to have a machine that could make anything you wanted? Sounds good, doesn't it? Well, this is now possible through the magic of 3D printers. And while you might not yet see a 3D printer sitting alongside your toaster or your TV at home, you will start to see them more and more in places like schools, in shops, in hospitals, and many other places. But what is a 3D printer, and how does 3D printing allow us to make almost anything from nothing? Well, first, we need to take a step back and look at how we normally make stuff. Basically, there are 4 ways we make things. The first way is called subtractive manufacturing. In subtractive manufacturing, we take a lump of material like wood or metal or stone, and we cut away some parts of it to make the thing we want. So, we remove or subtract, just like you do in maths, the material we don't need to create something. And this could be carving a wooden chair from a tree or making a statue from some stone. The second way of making stuff is called forming. And here we take a block of material and we apply a force to change its shape. My personal favourite of a formed object is Wallace and Gromit, made by shaping or forming plasticine. The third way we make things is called casting. And this is where you take a solid material, you make it into a liquid, and you pour it into a mold. And a nice example of casting, one of my favourites, is the way we make chocolate bunnies and Easter eggs. There's also a fourth way we make stuff, and that is called additive manufacturing. And this is where we have nothing to begin with, and you take your material and you add it exactly where you want it until you have your final object. 3D printing is one type of additive manufacturing, and it involves making an object by adding material one tiny layer at a time. So, how do you do that? Well, it all starts by making a drawing of the thing you want on your computer. The computer then makes a special kind of file which it sends to the 3D printer. And the 3D printer reads that file and prints the object layer by layer to make the thing you want. That sounds interesting, but why would you want to do that? 3D printing can help people to make new shapes and new objects that were not previously possible, and all sorts of different materials can be used, like plastics or metals or food, or even living cells that your body is made of. So, who uses 3D printers? Who cares about this? Engineers are using 3D printers to make parts of jet engines that are lighter and stronger, to make aeroplanes more efficient and use less fuel. Doctors are using 3D printers to make new hands and arms and legs that are perfectly fitted for the patients who need them. Even chefs are experimenting to make amazing new types of food that you just couldn't even imagine. And hospitals are using 3D printers to make new body parts for people, such as new bones, to repair really bad fractures, perhaps to the face or to the hand. And even using 3D printers to make objects from cartilage, the thing that your ear is made of, to make new ears for people who may have had a bad accident. One day, we may even be able to 3D print new organs inside your body, like kidneys or livers, using the patient's own cells in these printers. 3D printing is already changing the way we make stuff, and who knows what amazing things that you could make with a 3D printer in the future.
Thus, additive manufacturing provides significant resources saving compared to current methods. They are raw materials, energy, chemicals, as well as a lead time. The question is, how does repeat prototyping differ from additive manufacturing? The difference is in the use and scalability, not in the technology itself. Rapid prototyping is used to generate non-structural and non-functional demo pieces or batch of one components for proof of concept. Additive manufacturing is used as a real scalable manufacturing process to generate fully functional final components in high-tech materials for low-batch, high-value manufacturing. Additive manufacturing has advantages for small-scale production, allowing for higher production rates and design flexibility, along with increased cost-effectiveness per unit produced. Rapid prototyping allows designers and developers to create concept models and prototypes, as well as parts and assemblies for functional testing. The fields of application of additive manufacturing are mechanical engineering, medicine, architecture and construction, food and light industry, theater and cinema, as well as education. Research by Walls Associates showed that sales of additive systems for metal parts increased significantly in 2022. The development of this market segment is convincingly shown in this graph. Thus, additive manufacturing includes a set of inexpensive and highly versatile tools used for prototyping and fabrication of 3D objects. In most of the additive manufacturing techniques, materials are deposited layer by layer until a 3D object is reproduced. Several additive manufacturing techniques have been developed in the previous decades, and the application of additive manufacturing has increased in various industrial sectors. However, there are still drawbacks associated with additive manufacturing techniques that require further study and development. On the slide, you can see a list of recommended sources of information. Thank you for your attention.